Okay, dual credit, I'm going to go over a few things for your limiting reactant activity. So we started with, during our calculations, I gave each one of y'all a card. And so I walked you through how to change over from micromoles over to the units we needed. So since we are working with copper chloride in liquid form, we needed milliliters for that. And since we'll be working with aluminum foil, that'll be a solid, we needed grams for that. So we did that. So you've done this lab before. Um, you should be able to talk to me about the observations as you go through the process and you're putting them together. Just write down some observations, the color, any changes you see, temperature, etc. So one of the first questions I ask you is for the balanced equation, and hopefully you're not struggling with that you recognize the balanced equation is straightforward. Just make sure that you put your states of matter in that as well. We need to see that. Okay, so you do need to have your states of matter in there. The next part, the next question asks you about net equations, and this would be something that you're not as familiar with. Okay, this is probably your first time seeing that. All we do on a net equation is we're going to remove what we call spectator ions. And spectator ions, the way that we identify them, is they have the same state of matter on the left side as they do the right. So if I look, aluminum changes over into aqueous, copper is changing over. The only one who's staying the same between everything is the chlorine. It's still aqueous. So all we have to do is we're going to remove the chlorine out. And now, notice when I write my net equation, I do not write states of matter. And what I will do, I still have my coefficients out front, but I'm going to add a charge when they're in aqueous solution. So that's the reason I have copper plus 2 and aluminum plus 3. And that's how you write a net equation. We'll be working it throughout the year. So then it asks you for limiting reactant calculation. And once you do your lab, you should be able to tell which one's limiting because, like I said, you've done this before. And so it's pretty obvious if you have aluminum foil left over and the solution has gone clear, then copper chloride is your limiting reagent and aluminum foil is in excess. If you still have a blue solution and no aluminum foil left behind, then your aluminum foil is limiting and the copper chloride is in excess. So it's it's nice that the color changes there. It makes it very easy. But we can also calculate it as well. And so what I would recommend when you do this is I'm going to go back to my starting numbers of the millimole. Since an equation is written as molar ratios, I'm just going to compare my molar ratios. Do not get confused by the millimole. Notice, as long as I keep them both millimoles, the ratio is still the same. So all I did was I took my starting 12 millimoles and I changed it over from aluminum to copper chloride using the ratio from my balanced equation. I just put millimole as a label on the end and I get 18. So I need 18 millimoles of copper 2 chloride. I only have 14. That's my limiting reagent. If you're still like, I don't know if about that one, you could do your 14 millimoles of copper chloride, switch it over aluminum, and I need 9.3. I have 12. So I have enough. So it is copper chloride that's limiting. The reason you need to know this is because you're going to be asked to draw a particle diagram. The main thing on the particle net ionic diagram we're looking for is if copper chloride is limiting, then when you get done with the reaction on the end, I should have plenty of aluminum and not enough of the copper chloride. So I ran out on this one, and that's why I drew my ratio like I did. Okay. A few tips on that is since I have a solid, I make sure that I draw my solid like a solid, and then I make sure I draw my aqueous kind of sparse and wherever it wants to go. Okay, that's what I'm trying to represent there. A1 of your report is we're gonna decide as a group what the order is based on our visual cues, and then A2 we're going to use the spec and we're going to put those results in, and hopefully y'all did a great job that A1 and A2 match. Then on the post lab, the first question they ask you is the type of reaction, and so I know that most you're going to key on, you're going to say that's a double replacement reaction. Absolutely. So now we get to classify double replacement reactions with another qualifier on top of that. And so since I have aluminum changing from a charge of 0 to +3 and copper changing from +3 to a 0, we call that a redox or oxidation reduction reaction. A little pneumatic device to remember by is Leo-Ger. So if I lose electrons, I'm oxidize, and that would be the aluminum. If I gain electrons, I reduce, and that's the copper. So, new. In the next question is asking about endo or exo. Hopefully you felt the test tube while it was reacting, and hopefully you felt it was warm. I've had some students in the past who also grabbed a temperature probe and checked it and measured that there was a difference. Okay, but it is exothermic, and just cite your reasoning for it. All right, question 3 is asking you about that supposedly a group that had 0.16 grams of aluminum and 24 milliliters of 0.1 molar copper chloride. Ooh, I just made a mistake. What the limiting reagent is, so I'll let you fix my mistake. It says 0.1 molar, so you will need to fix this right here. Instead of 0.5, you need to put in 0.1 and recalculate that one. Okay? And find out if it still is copper chloride, that is our limiting reagent, but do fix that one. All right. And then number 4 is asking you to finish out the particular diagram, what the reactant looks like. So hopefully you have something along the lines that I have there with your solid at the bottom and also proportion out between your aluminum and copper. Okay, last thing I'm going to mention on this, because the point of this is to get you back into stoichiometry and limiting reagents. I'm also have a review for you as well, going over some stoichiometry problems. Okay, so I just set up, and it should look similar to your first problem on the page. I have an equation, aluminum hydroxide plus hydrochloric acid yields aluminum chloride and water. So what the first thing you're going to have to do, and the reason there's blanks underneath y'all's, is you have to go in here and you have to figure out what the formula mass or the molar mass is for each one of your substances. And just recall, we're just going to add up our atomic mass. So that's the decimal number. Since you're in dual credit, you really should hang on to at least 2 past decimal. Okay. I just was doing this really quickly, and that's the reason I just kind of rounded my stuff. So, again, I have aluminum hydroxide. I've got 1 aluminum, 3 oxygen, and 1 hydrogen. When I get that all said done, it adds up to 78 HCl. I have 1 hydrogen, 1 chlorine. Added up, that gives me 36. Aluminum, 3 chlorines. I add that up, I get 133. And then hydrogen and oxygen for water gives me 18. Okay? So my example problem, I'm given 3.750 grams of aluminum hydroxide. I want to know how much HCl is needed, and I want to know how much water is made. Notice that my equations are all set up the same way to right here. I start with the same thing. Oops, too much fun. I start with the same starting point, 3.750. I'm going to convert that over to moles. Once I have it to moles, I go back to my balanced equation. That's where these numbers come from. There's a 1 here. There's a 3 here. That's where that comes from. And then I insert my molar mass again right here. Okay? Once I have that done, remember it's always the product at the top divided by the product at the bottom. Okay? Your calculators, the alpha X works really great for putting in fraction form. Okay, and then you repeat that also to find out how much water you made. And hopefully that starts coming back to you. And that's all I have for now. All right. Live long and prosper.